So in this video, we're going to consider speeding up. And so we're going to do the same thing as we've been doing. And I want to just note here that this is constant acceleration where the velocity is changing by the same amount every time. There is a such thing as not constant acceleration, but it's very complicated and much more challenging math, and we're not going to consider it in this class. So we are just keeping with constant acceleration, and we're going to look at speeding up separately from slowing down. So what do we know about the velocity if something is speeding up? Well, I think we can say that it's changing, right? And the acceleration should be a constant because it's constant acceleration. So we should be able to fill in here at the top that the velocity is changing, the acceleration is equal to some constant. So this is another time for you to really focus because this can get very confusing relatively quickly. So when a car is speeding up, the distance is changing as well as the velocity is changing. So if the speeding up is at a constant rate, that means the velocity is changing by the same amount in each time interval, kind of like what we saw when we were looking at the numbers and in the tables for the different things that were moving at constant acceleration. So, but the distance covered is not changing by a constant amount because as they speed up, they're going to cover more and more distance. It's kind of like being at a stoplight. It moves forward a little bit at the beginning, but during the next time interval, it moves more. And so the distance traveled is more. And then the next time it moves even more. And eventually it moves a really large amount. So let's try to fill in some numbers here and still consider that we think about what's really happening as the vehicle is speeding up. So let's see if does this kind of agree. So I am going to use red here. If you want to stick with the same colors, that's fine. And if you don't, it's okay too. So acceleration, I'm setting equal to 4 meters per second squared just because I wanted to have a value here. And the velocity I'm starting out is at 8. And that increases by 4 meters per second each second. So it goes to 12, 16, 20, and 24. And with the distance traveled, should go farther and farther each time interval. So in the first time interval, it goes by 10. The next time interval, it goes by 14. The next time interval, it goes by 18. And the next time interval, it goes by 22. So that corresponds with what we just said about what happens when a car speeds up. So let's take a look at the graph. So if we graph this, we're going to see that the distance changes a little bit at the beginning, but it more and more as time goes on, and it almost ends up with a vertical line. And I'm sorry, this isn't a really pretty curve. It was really challenging to draw in the notebook, but you hopefully get the idea. The velocity is going to be a straight line with a constant slope. Remember, acceleration equals change in velocity divided by time, which is the slope, which is really awesome because you can actually just read the slope right off the graph and get the acceleration. So the red line here has a positive slope, so that means you have positive acceleration, okay? And if I do my blue line, you're going to end up with a line that has negative slope and negative acceleration. So if I do the same information, I didn't plot it for the blue, but you could have the same thing, but you're going to have negative numbers here. So your distance is going to change a little bit at the beginning and increase much more rapidly as time goes on. And your velocity is going to have a negative slope on this velocity versus time graph. And since the slope is negative, you're going to end up with a negative acceleration. Remember that whole positive acceleration, negative acceleration, and you could have them if you were speeding up. One would be when you're moving in the positive direction. The other one would be when you're in the negative direction, because negative direction and speeding up would be a negative acceleration. See, it's coming back. So what do you think about forces in equilibrium? Are we balanced or unbalanced? Do we know what the net force is? And is there any type of equilibrium? Well, hopefully you recognize we've got unbalanced forces this time. Net force is not equal to 0, and there is no equilibrium going on when we're traveling at constant acceleration. Free body diagrams. And ticker tapes. So starting with the ticker tapes, what happens to the dots when you start drawing on them? They get farther and farther apart, right? So if we consider the fact that the acceleration for this is to the right and it's speeding up, then it basically means we need to have our overall pushing to the right also. So the unbalanced forces must indicate an overall net force to the right. So you're going to end up with something like this. They're going to be spreading farther and farther apart. And your net force is going to be in the same direction as your acceleration, which since you're speeding up and you're traveling this way, the acceleration is in the same direction. If you are moving to the left, you're going to have a similar thing where your dots are going to get farther and farther apart. But remember, you're starting on the right and you're traveling to the left. And in addition, your acceleration is going to be to the left. And so your net force also has to be to the left. So you're going to have something like this. Now, there can be vertical forces, but they have to be balanced. Most likely there are vertical forces because on planet Earth, we always have gravity as a force, which we'll talk more about in the next chapter. But most often you do have vertical forces acting on your objects. So then you're going to have, this is your summary sheet for speeding up. So again, you're looking at distance versus time. They're going to be these curves, and they're going to be very steep as they continue on. Your velocity versus time are no longer horizontal. They're going to have a slope, and the slope gives you an indication about what the acceleration is. And we have some information about unbalanced forces, and they kind of give you information about what the acceleration is going to be doing. So in the next video, I will talk about slowing down.